Hi, my name is Justin, and in this video I'm going to be demonstrating how the Analog Rails Optimizer automatically changes properties to meet specifications that are based on AC, DC, and transient analysis all at the same time. So to get things started, I'm going to zoom in on these components here in the schematic. You can see that I have an AC and transient analysis test benches. If I open up the AC analysis test bench, you can see that you can change the variables. You can also set up your analysis parameters. And the same options are available in the transient analysis test bench. If I open up Sim Globals quickly, you can see that the variables are also available here, as well as parameters to set up your corners. You can see here in this pull down that we have a variety of built-in measurements in the tool, and we can add ones at customer's request as well. And I'm going to open up the bandwidth measurement properties here, and you can see that the circuit designer can add differential nets. They can specify the targeting cost and other parameters as well. So now I'm going to zoom out on the schematic and start talking about the hierarchical editor. Here on the right you can see that the hierarchical editor represents the full hierarchy of the design. I can cross probe. You can see I click the circuit 124 in the hierarchical editor. It is cross probed in the schematic and vice versa. I can also descend the hierarchy in both the schematic and the hierarchical editor and cross probe below. I'm going to descend down into circuit 8. Scroll down here, you can see I have a variety of optimization matches. These cross-probe as groups. I can also expand them in the hierarchical editor and cross-probe the individual devices. Optimization match groups are created by clicking the O equals button and then clicking on the individual devices that you want to be optimization matched. So now I'm going to ascend the hierarchy and click the O button to start the optimizer and bring the optimizer GUI forward. The optimizer is going to initialize, and then I'm going to set 5 good runs and run a local normal optimization. And you can see that the optimizer is going to work. You can see the simulator running here. In the results area, you can see the target and cost parameters that were set up in the components in the schematic. If I scroll down here, you can see a variety of those. You can also see that the lengths and widths are changed. These are for each of the devices in the design that were optimization matched. You can also see that the failing parameters are red and the ones that pass are green. And you can also see on these tooltips that the optimizer always shows you the results of the worst corner, so you can run AC, DC, and transient all at the same time and pass the spec on all corners. Right now you can see that the optimizer is honing in on a good run. You can see the cost getting lower and lower and lower. It's showing these in red to indicate that we have not yet passed the spec, but that we are getting closer. The best results are always shown to the left. And here you can see we are now getting good results with a cost of 0. And it's going to stop when it hits 5 good runs. The optimizer is now stopped, so I'm going to select a good result and click Apply and Open. What the tool does here is it's going to make a sandbox of this design that's time-stamped. And this is to prevent any changes from happening to the original design. Right now the tool is regenerating the devices in the layout and we're ready to go. The new optimizer properties have been applied. So now I'm going to go ahead and run a new simulation. You can see that we have past results here. All the simulations have passed. So I'm going to go ahead and probe the AC again. You can see the new results and the old results together. And that'll be even easier to see on the transient results. There you go. You can see that the ripple effect has been reduced. The newer simulation result is in blue. The old result is in gray. Also, if I click the net button here in the common toolbar, you can see that the voltage parameters have been back annotated onto the schematic. And if I descend the hierarchy, you can see that the operating conditions have been back annotated onto the devices. This has been our demonstration of the functionality of the Analog Rails Optimizer. We hope you enjoyed it, and please enjoy the rest of the videos on the site.